How would you describe the glazing strategy used in this building?
It's quite interesting actually, the glazing strategy, because right from the very beginning of the building's design, one of the things that was pretty paramount was to reduce the amount of solar heat into the building during summer, and also promote the amount of solar heat in the winter time to try and provide a passive response to the heating and cooling to the building. And one of the things you'll notice with this building is that most of the glass is actually on the north facade. And so it's actually taking advantage of winter sun coming into the building, and also preventing solar sun through the external shading from actually coming into the building and hitting the glass at the same time. On the east and the west of the building, there's very little glass, and the reason for that is that when the sun is low in the horizon on the east or the west, then the minimum amount of glass means there's minimum amount of solar thermal that needs to be offset by the air conditioning system and treated. In that way, the building responds very well. Similarly, on the south, there's very little glass, so that the amount of solar loss during winter time in the southern facade is minimised. The glass itself is made up of double glazed units, and the reason for that is to minimise the amount of thermal conductivity across the facade from inside to outside. So when it's very hot outside, then some of that heat doesn't come through, and when it's very cold outside, it works in the opposite direction. However, one of the important things for the architect was to try and have a very high level of visual light transmission, and they've achieved that by having a double glazed unit with a very low emissivity coating on surface 2 of number 1 glass, which was the outer glass panel. And the way that works is that as the sun hits the outer pane, it actually gets very hot, and it loses that heat to the outside and then also some to the inside. The double glazed unit prevents any of that heat in the cavity coming into the building, and to stop any radiation of heat going into the space, the low emissivity coating actually stops that radiant heat coming from the outer pane going into the building. And so in effect, what you have is a glass which can have a very high light transmission, and of course a very low solar heat transmission through the glass at the same time. The benefit, of course, of having very high light transmission through the building is it means, firstly, you can see the colours. You can see a very good colour of the blue sky and the green of the trees and such like. So it's very pleasant, and that sort of provides a lot more daylight into the space, which allows you to reduce the amount of electric lighting happening, and also makes the place feel a lot more like outside.